Happy Friday, everybody, and thank you for joining us today for our webinar on a how-to guide to two-way wireless products. We are super excited to be doing this webinar today. We do have a complete line, we feel like, now that we just announced the recessed door contact earlier in October. And so we really want to just go through all of our products with you, give you all the features and benefits, the insides and outs of each product, also how to enroll the sensors, and just all the nitty-gritty. So thank you so much for joining us, and if you have any questions at all throughout the webinar, make sure to put your questions in the questions box in the right-hand side of your screen, and we will get to as many questions as we can. Any unanswered questions we will answer in a follow-up email next week. This webinar will be recorded, so we will be sending you a link to the recording along with the PowerPoints and other useful resources. And you can check out all of our recorded webinars in addition to other how-to videos on our YouTube channel. So just go to our website, click on the YouTube link, and you have all access to all our training videos. I do want to remind you all that we will be at ISC East next week, so come by, see us, say hi to Trudy and Kirk. We're super excited to be up in New York next week, so definitely check us out. But further ado, I'm going to pass this along to Amy Strickland. She's our tech support queen. She also helps us with marketing. All of y'all probably have talked to her if you call into tech support. But I'm going to pass this on to you, Amy.
Thank you, Jessie, and thank you everyone for joining us today. We are going to spend some time going over two-way wireless, so let's just hop right in. So what makes two-way wireless better than the traditional wireless that you're used to? You can think of it as you have a receiver and you've got your sensor. The receiver only has the capability to listen for signals from the sensor, which is just a transmitter. So when the transmitter is activated, all it can do is just blast out a bunch of signals, hoping that at least one will get through to the receiver. It doesn't know whether or not that actually happened, so it does what it can to make sure it gets enough signals through, and then it just stops, not knowing whether or not it actually worked. So with two-way wireless, you kind of eliminate that question mark of, did the signal actually get through? So, you have a sensor that becomes violated. It's going to send a signal to our transceiver. The transceiver is then going to send an acknowledgement signal back saying, hey, I got that signal. You can, stop trying to send. So you've got more reliable communication there because you are getting that acknowledgement, but it also helps save with batteries, which is a big thing with wireless, because you're not having to just blast out a bunch of signals at full power. It can send a signal, wait to get the acknowledgement. Once it gets that acknowledgement, it stops. So there's definite benefits there with the reliability and also with the battery life using a two-way product like ours. Our two-way wireless does offer some advantages, some definitely some advanced features that help it to be more reliable, to make it easier to install, and also some really neat security enhancements in some of the products. So again, we talked about the positive signal acknowledgement. Again, that's just where it's getting the signal back from the transceiver, letting the sensor know, I got the signal. We also use a frequency hopping method, so we're in the 900 megahertz range, and we are able to change frequencies. If we find that one frequency is not working for us, we can change to another one, and that again just it's going to make sure that your signal gets through. You have status LEDs that can give you some information as to whether or not a signal was acknowledged, and also with something like our Keyfob, you're going to also get some status information from the system as well, so that's a neat benefit. And then of course we have adjustments to the power level, so that if a sensor, say, is fairly close to the transceiver and it doesn't need to be sending its signal at full power, it's going to make an adjustment to send the signal at a level that's going to make sure that it gets through, but also maximize your battery life. Okay, so here's our line of two-way wireless products, and as Jesse said, we have added the recessed door window sensor and also the glass break sensor in the past couple of months, so really rounding out the product line pretty nicely with those two additions. We've got smoke detectors, number of different door window sensors. You've got your Keyfob, a panic button, and then of course your transceiver, which is the way that we interface all of these great products to our M1 control. Let's talk a little bit more about our transceiver. It does connect to the M1 via the data bus, so you've got that 4-wire connection to the data bus, or if you're using a data bus hub, you may have a Cat5e or Cat6 run to that, but you are going to have a wired connection from the main control panel to this transceiver. It's really important that you do not mount the transceiver inside the enclosure with the M1, as the metal housing, the enclosure, the can, is going to have an effect on the range of that, and we wouldn't want that to happen. So definitely want to have that mounted outside of the main control panel, and that's why we provide the nice plastic housing that you can mount above or in some other area. You may even want to remotely locate that to a more central location in the building. If you are covering a larger area that maybe one transceiver is not going to be able to cover on its own, you can have additional transceivers. You can have a maximum of 4 of the M1 XRF-TW transceivers connected to the data bus, so that does allow you to cover a larger area. Now, one thing that's really important with this transceiver is the addressing. So the data bus address for the first transceiver must be set to 2. And then if you have additional transceivers, they need to be addressed sequentially following that first one. 3, 4, and 5 would be valid addresses. So you have addresses 2 through 5 that could be valid for a transceiver, but again, your first one always has to be at 2. You cannot have any hardwired zones in the area or the groups in which the transceiver is located as far as the address is concerned. So this typically, when you're doing a new installation, knowing this information up front is not going to be a problem. You just need to make sure that you address and enroll everything correctly and you're good to go. This becomes more of a concern if you are retrofitting or you're adding the two-way wireless to an existing M1 installation, where you may already have like a hardwired input expander at address 2. If that's the case, then you do have to remove that expander from your programming, change the address and re-enroll it, and then set your zones up to match the new address. So that is a manual process to add the two-way to a system where you may already have an input expander. And if that's something that you run into and you want some help with that, just to make sure that you're getting it done right, just feel free to give us a call on tech support and we'll make sure that you're on the right path there with your addressing. Now let's take a deeper look here at the inside of this transceiver. Again, as you can see, you've got your 4 screw terminal connections for the data bus, and then there's also a terminating jumper for the data bus. These are standard things that you would see on any data bus related device. So if the transceiver is at the end of a data bus run or on a run by itself, depending on how you have it set up, you may need to install the JP1 jumper, which is located here. We do have this quick connect here that you can use to connect this to the panel. You would use one or the other of these, but you would have no reason really to use both. There are some status LEDs and RF LEDs on this to give you some indication of what's going on. So the status LED should just give you a steady 1 second blink, 1 blink per second, just on off, and that should remain steady. You shouldn't see that LED go solid or blink rapidly for really any reason. If you see that, then there's some kind of issue. The green LED will only blink when a learned sensor is activated. You'll also see the amber LED, which is just an RF LED blink when traffic is detected. So if you have a learned sensor and you trip it, you're going to see the green and this lower amber, the all RF LED, are both going to blink, indicating that a signal came in. There's another LED on the board here, and you would not see this one with the cover on. These other three you can see through the cover, but this one you can't. This just shows data bus activity, and you're just going to have like a continuous a flicker or blink on that LED, and that's what's considered normal there. We talked a lot about the addressing. The dip switches here are how you're going to set those addresses, and 2, 3, 4, and 5 are the only valid addresses for this transceiver. Okay, let's talk about our 4-button key fob. This is the ELK 6010. This allows you to arm and disarm. You can activate panics. You could set up automation tasks or program the buttons to say open your garage door or something like that. All of that programming is done in the ELK software, and I will show you that here in just a moment. You can access the programming for the buttons from the keypad as well, although that's not as easy as using the software, but we can go through that here as well. This is a sealed key fob. It does not have any way for you to get inside of it. It's a welded case so that it can be water resistant, and that does mean that the battery is non-replaceable. The key fob has an inquiry button. Button 3 here, our blue button, is what we consider the inquiry button, and that allows you to request the status of the system as far as whether it's disarmed, armed, or has an active alarm. And you get that information back to you through this bicolor LED. So green means it's disarmed, red means it's armed, and if you get flashing red, then there is an active alarm. And you can call up that information at any time using the inquiry button. The ELK 6011 is a panic button. It's a single press and hold button, and it has a red LED feedback indicator. So when you push the button and then the signal goes to the transceiver sends an acknowledgement back to the panic button, and that's when you're going to see that red LED come on, indicating not that the signal was sent, but that it was actually received by the transceiver. This is, again, ideal for panic or emergency alarms or, hold-up kind of situation. We do include a water-resistant lanyard with it that does have a breakaway connection so that it can be used for monitoring if someone wants to have that on their person in case they fall or have an accident or just need help. They'll have a quick way to call for help. And this also has the welded case for water resistance, and again that means that it does have a non-replaceable battery. All right, now we're going to get into the door and window sensors. We'll start with the ELK 6020, which is a slimline door window sensor, good for door and window jambs that are narrow. You need to have a more narrow device to mount to that door or window. This is going to be a great option for you. It has a front and back tamper. You can see that there is a little actuator that goes into the back plate that will provide that front and back tamper. So if the cover is removed, the tamper is activated, or if the back plate is removed from the wall, it would also be activated. And that's all handled through this one actuator that goes into your back plate. You've got a label on all of the devices so that you can easily learn those into ELK, and we'll do that in just a bit, but you can see where I've pointed that out on this particular sensor. And it's really important that you observe battery polarity, so definitely take a look at that when you're installing these products and make sure that you're inserting the batteries in the proper orientation. If you put the batteries in reverse polarity, then it may damage the sensor, so definitely pay attention to the polarity, and I've pointed that out for you here as far as how the battery should be inserted. Now, one thing that I didn't mention about the tamper that I want to let you know is you can have this device tampered or not. That's an option for you as to whether or not you actually install the little actuator in the back plate. You can choose to leave that out if you do not want it tampered. When you do put that tamper in and you put the battery in, put the cover together, the tamper is going to be automatically enabled at that point. If you were to at some point later want to disable that tamper option, you would actually have to take the battery out, remove the actuator, and you would need to leave the battery out for a good 60 seconds or so before you put it back in, so that it kind of resets the sensor to know that it doesn't need to send tamper related information. We offer the mini window sensor. This is a very thin sensor that is really good for double hung or casement style wood or vinyl windows. It uses a coin style battery, and you want to have the positive up on that. There's no tamper option on this particular sensor because it is so thin. Another thing to make note of, because of its size and how close it is to the mounting surface, the range on this particular sensor is not as high as it is on some of the other sensors, so you want to be sure that you're within about 100 feet of your transceiver when you're using these thin 6021 mini window sensors. The next sensor we'll talk about is our universal 3-zone sensor. This is the ELK 6022. So you can secure up to 3 doors, windows, etc. with this. It has a reed switch built in, which is your loop 2, and then it has 2 zone inputs for external contacts, which are loop 1 and loop 3. It also has the same front and back tamper option that I was talking about with the 6020. With the actuator installed, you can actually have that tampered, or you can leave the actuator out and it will not be tampered. That's your choice. Again, make note of your battery polarity here as far as how the battery should be inserted, and this one's using one of the CR123A batteries, so it's a slightly different battery than we saw in the 6020. Taking a look here at this part of the circuit board, and I've kind of blown that up here, you can see where you have your connections for your external contact, loop 3, negative, and loop 1. So the loops do share a common negative, so you've got 2 different zones there that you can work with. You do need to set that loop number in programming so that the sensor or the zone knows which part of the sensor it's working with, and you can have this same ID number learned into 3 different zones set at 3 different loop numbers to access all of the possible zones off of this sensor. Now, by default, the sensor is set, or the sensor is set up for normally closed contacts on these loops 3 and 1. But if you do want to use normally open, you can select option 2 in programming to enable that as a normally open instead of normally closed. And once we get into the software here in a minute, I'll show you where you can make that selection. If you are using external contacts, we do have a little breakout slot here in the back plate for the wires to come through. All right, now let's talk a little bit about our recessed door contact. This is a new product for us. This is our latest addition to our two-way line. It's designed for wood and vinyl doors, and it is able to be recessed so that you don't see it at all once the door is closed, which is really good for discriminating customers who don't want to see something hung on their door or their door frame. It does have a micro tamper switch, and it mounts into a 3/4 inch drilled hole. So you can see the housing here, and it has a little circuit board kind of sliding down in it. There are some notches there to help you align that once you've pulled the circuit board out, which you're going to need to do to install the battery. Again, making note of the battery polarity, and right here's your little micro switch. That is actually engaged by the cover, and you've got your label here for your ID, so that you can learn it into the software. And I'm actually going to show you here in just a bit learning one of these particular sensors in through the keypad, but I'll also make note of some things in the software when we get to that point. Alright, now let's talk about motion sensors. We offer two different motion sensors, a standard and a PET immune. The PET immune is up to 40 pounds. So you've got two different part numbers there, again the 6030 and then the 6030P indicating the PET immune version. Both of these have the security and convenience light, which is a very bright white LED that is able to cast a good light out into the room. You can use that for alarm activation. You're going to get flashing on that LED. You can have it momentarily activate during the walk test mode so that you can really see from across the room whether or not the motion picked you up, instead of trying to look from across the room and see a small LED, or either going back to the keypad to see if it picked you up. You're also going to be able to initiate that walk test from the keypad, so there's no need to climb a ladder and take the cover off or press a button inside of the motion detector to put it in walk test mode. You go to the keypad and you put the keypad in walk test mode, and then the motion itself is going to be in walk test mode. You also have the option to program this LED to turn on based on rules, and we'll go over some examples of that here in just a moment. So we've got our motion front facing here, but it also has a creep zone here that's kind of looking down so that you can't try to slip underneath it. It's going to see you. Now we take a look at the inside of the motion detector. You can see that it does use two batteries, and one of the primary reasons for that is to supply extra power for that LED that I was just talking about. So definitely need to be using both batteries when you're using this motion detector. You can see there's a hole in the back plate, and that's to accommodate a few different mounting options. There's a plug that you can install in that hole if you're just going to mount it on the wall, and if you do that, you insert the plug here, and then you can kind of see these little dimples in the back of the back plate here. Those are to help you get your screws started, so you would use at least two or more of those dimples to start your holes for a wall mount situation. We also include a standard swivel bracket with the motion detector, and so you can use that if you need to have some swivel in it. If you need a lot of swivel, we do offer a deluxe 90-degree swivel bracket sold separately. That is the ELK 603022. So if you need to have more swivel in the mounting bracket, we do offer that as an option. There is a tamper switch on the motion detector, which is engaged by the back plate or the cover when you put that on. Once you pull that off, you're going to notice a row of dip switches here. These set a number of different options for the motion detector. The pulse count and the range are settings that you can use to make the sensor more or less sensitive, so to speak. We have a sleep cycle. Now that has to do with how long the motion detector will ignore activity after being tripped. So you walk by the motion, you trip it, and it's going to ignore activity for a certain amount of time after that. You can have that either be a short amount of time or a long amount of time. And the short time on that is going to be, I think it's 30 seconds. I'm just wanting to just double check that right quick. Yeah, it's 30 seconds on the short and 120 seconds on the long time on those. You can use the number 4 jumper there to set the security LED as to whether or not you actually want that on or off. So you can set that to no, and it will not use that security LED. There's also an option for the acknowledgement LED, and so those options are there for those situations where you really want to extend the power life of the motion detector, so you don't necessarily want those LEDs on. In some cases you have that option in programming. And of course we've got a label here with your ID number on it so that you can easily learn that in through the software. So now let's dig into a couple of examples where if you wanted to use the security LED and control it through rules, there's a couple of different options there. And the way that we do this is using outputs 4, 5, and 6. Now these outputs do not physically exist on the board, and they're not accessible in really any way. They're skipped over on the main board, they're not used, so they're basically phantom outputs. They could not ever physically be connected to anything, they just don't exist, but we can manipulate their state through rules, and by doing that we can control how the light activates, or when it activates, I should say. So if you have output 4 on, then the light on the motion detector is going to come on for around 17 seconds when motion is detected. So you can see a rule example there. I have that coming on about 15 minutes after sunset and then turning back off at sunrise. So I'm basically making a night light, so to speak, out of the motion detector. It senses motion, it's going to turn on, but only when it's dark outside. So we can use output 4 to control the on solid activation when motion is detected. Now output 5 can be used to control the flash on, and so we can have it flash for about 30 seconds by turning output 5 on. That's going to it's automatically going to time that for around 30 seconds. So you're really not going to have it flashing for any longer than that, but it's good for a visual indicator. Maybe you want to indicate to everyone that it's that dinner's ready. You can have maybe an F4 key or something to activate it that way, or the example that I've shown here is to draw attention to the fact that the telephone is ringing. This could be good for someone that maybe needs a visual indication that doesn't hear as well, or perhaps it's you're vacuuming and you just don't hear the phone. You're going to have something to give you more of a visual indication that the phone's ringing. So ideally you want to turn output 5 on for 38 seconds, and the reason that we choose 38 seconds is it could be 8 seconds before the motion detector is going to respond to a command that we send to it this way. That has to do with the two-way communications, and so it wouldn't be more than 8 seconds. It could be up to that, so we want to account for that, and also the time that the light's going to flash, which is again is predetermined at 30 seconds. So that's how we came to that number. All right, now output 6 will control the solid on. And again, that's going to turn on solid for about 17 seconds. And so we have an application here where we're turning that on when the entry delay starts. So we've just violated our entry exit zone, and the entry delay has started. If it's dark outside, then we want to go ahead and turn that light on just to give a little extra light, and also to draw attention to the fact that someone's opened the door. So again, we want to tack on about 8 seconds to our 17-second activation that we're going to get, and that's where we come up with this 25-second activation.
Amy, I have a question. What is the battery life if you make the PIR or the motion detector short, like 30 seconds in sleep cycle? Like, what's a typical battery life?
The battery life is really going to depend on the use of the motion detector, whether or not you're using these lights and that sort of thing. Typical battery life for the motion detector is going to be somewhere between 5 and 7 years, but it really does just depend on how it's being used.
Thank you.
You're welcome. Okay, this is another new product that we've added to the line in just the last few months, and this is our glass break sensor. That's a mouthful for me right now for some reason, but it actually uses a technology that allows it to detect the pattern of breaking glass, and to a level where it could tell the difference between a framed piece of glass being broken versus you've dropped a wine goblet in your kitchen. It's going to know the difference between that just from the sound and the patterns of the breaking glass. The detection range on it's 20 feet at 360 degrees. It does have an omnidirectional microphone. From the front with the cover on, you do have an activity and an alarm LED that you can see without removing the cover. There's also a status LED to give you that bidirectional, red it didn't get it, green it did, but that's under the cover, and you can see I've pointed out the location of that LED here, which is good for troubleshooting, but you're not going to see that when the cover is on, and there's really no need to. Again, make note of your battery polarity here as far as how the battery should be inserted. We don't want that to go in backwards, and you should see a label in this area with your ID number on it. So for testing the glass break sensor, I mean, you can, just like clap near it and you're going to see that LED kind of come on just to indicate that it heard something. But if you want to actually test it and alarm, you are going to have to get a device to simulate the sound of breaking glass. And I know that there is one available that we recommend in our documentation for testing. We'll provide those details in our follow-up email. Okay, now here's another really interesting product that we have in our two-way line that has some unique features because we are using the two-way wireless. So the big thing there is the sound off feature, and what that does is basically wirelessly interconnect your smoke detectors. So if one smoke detector goes off, it starts to sound, sends its signal to the control, and then the control tells all of the other enrolled smoke detectors to activate their sounders. So all of the sounders go off together when any one of the smoke detectors is activated. And really this is whenever any fire alarm is activated, you're going to get all of the sounders going off on all these smokes. Now a lot of areas are now, code requires this sort of thing as far as your smoke detectors being interconnected, and that can be really hard to achieve in a retrofit situation where you can't run wire in between the smoke detectors. So this is going to be a great solution for those problems, for those situations where you just can't run that wire and you need to have that interconnect. In addition to being able to detect smoke, this device also has a rate of rise and also fixed temperature heat detection. So you've got some heat detection built into it. And it is UL listed. So that's very important when you're working with fire systems. So we are taking a look now at the inside of the smoke detector with the back plate removed. You'll see that there is a magnet there to activate a tamper so that it does know when the back plate's been removed. Some notches here just to help you line that up when you're trying to put that back on. Make note that you can't put the back plate on the sensor when there are no batteries in it. It has a feature to prevent that from happening, so just be aware of that. It does take 2 batteries. It does need them both, so be sure to install both batteries when you're installing this sensor. And of course we have a label there with our ID number on it for you. Now once you remove the back plate, there is a separate little cover for the battery compartment, so just be aware of that. And it's really easy to remove that battery cover, so it's not a big deal.
I just want to interrupt real quick and just because I have been getting a couple of questions about a carbon monoxide detector, and at this time our engineers know about that we need this product in our product line, but at this time there's no word on when this will be added. So just to let everyone know, at this time we don't have a carbon monoxide product, but who knows in the next year if we will or not. So we'll keep you posted if anything changes. So I just wanted to let everyone know about that.
Thank you. Okay, so now it's time. We've went over all of the sensors and tried to familiarize you with the the insides and the different jumper options and settings and whatnot, different locations of battery polarity and all of that. Now we want to talk about how you enroll these sensors in the system. There are two different ways to do that, and we're going to go over both of those. We're going to start with manual enrollment from the keypad. Now I've got in this presentation step by step how you do this, but what I really want to do is show you. So what I'm going to do now is turn on my webcam. So give me just a second there. Now you should see a small viewer on your screen that allows you to see this keypad that I have my fingers in front of here. If that seems really small, you should be able to resize that on the screen yourself. So you take a moment and locate that and resize it if you need to, so that you can follow along as I'm stepping through this process. All right. So what I have here is the 6023. You can see this is the main part of the unit with the housing. It's very easy to remove the cover with a small screwdriver, flat screwdriver. You just need to very gently pry up there and the cover will pop right off. You can just pull that out as such, and you can see the circuit board inside here. So we're going to pull that out, and if we were learning this in through the software, we would have our ID number here on this label, but we're actually going to learn this in through the keypad. So I've got my circuit board out and ready to go. I've got my battery here, making note of the polarity and the way that it's going to go in, getting that ready. Now I'm going to go through the keypad and enter the menu that's going to allow me to learn this in. So I'm going to press the ELK key and then 9, which will take me to installation programming. Right arrow into that, and it's looking for an installer code. The default is 172839. Now I want to go into menu 14, which is wireless setup, so I can just key in 14. Right arrow there. And now I want to go to option 3, which is my learn wireless transmitter option. And I'm going to right arrow into this menu. Here you're going to select the zone to learn into. I'm going to learn this particular sensor into zone 17, so that's working for me, but if you needed to select a different zone, you can key in the zone number here. And this is the transmitter that I want to learn into this zone, so I'm going to go ahead and press the right arrow key, and now I'm being instructed to push transmitter button. Now at this point I'm going to install the battery into the sensor. And you'll notice there, as I got that battery fully installed, you heard the chime, and you can now see that the keypad has advanced to zone 18. So I mean, that's all there is to it. I've learned this sensor in. I'm going to go ahead and put my circuit board back down in here, aligning it up with my notches, and install the cover on this sensor, and that one's learned in. So you can see that it has like a rapid enroll feature where it's going to go ahead and advance to the next zone, allowing you to quickly go around and learn in all your sensors. So I've got this Keyfob here. I'm going to go ahead and learn it into zone 18, and I'm going to do that by pressing and holding the lock and unlock buttons together. And you can see that just like that I've learned in this Keyfob. So it's just that easy. When you're done learning in sensors, you would want to press the ELK key to stop the rapid enroll feature. And now I want to go back to my other zones that I learned in. So you can see here on the zone 17, it shows that it's enrolled. It shows me the ID number. This ID number is the one that's going to match your label. This is exactly what's on the label of the sensor I just learned in. Now, with some sensors, it's really important to set the loop number. So I'm going to show you how to do that. You're going to press the left arrow key here, and you can see this number really doesn't mean anything to us, but we have our loop number here. So if I needed to set this to loop 2 for that sensor, I right arrow there and then just key in loop 2. And now I've set my loop number. So that's how you do that. Now there's one other thing that you would need to do when you're setting up wireless sensors, is the supervision. Now most sensors are going to be normal supervision, but there are some exceptions like the Keyfob that I just learned in. So I'm going to show you how to make changes to that from the keypad as well. I'm going to press the ELK key and then ELK again, and then ELK again. And you can see each time I'm pressing the ELK key, it's taking me back a level. So now I'm at my 3 Learn wireless transmitters. I want to go down to menu 2, which is my transmitter options. Right arrow into that and then select the zone. Now I learned my Keyfob into zone 18, so I'm going to go up to zone 18, or you can just key in the zone number, whichever is quicker for you. Right arrow there, and you can see that this is an enabled transmitter. It says yes here. That means we have something learned into that section, that zone. So I'm going to up arrow here to go to the next item, which is supervision. Now you can see it defaults to normal supervision. That works for your door window sensors, that sort of thing, but that's not going to work for this key fob that I'm going to be carrying around with me. So I want to press the right arrow key there and then press 0 to change that to no supervision. That's what you're going to want for your key fobs. That's what you're also going to want for your panic buttons, things that people are going to be carrying around. Now, no supervision is 0, normal supervision is 1, and fire supervision for your smoke detectors is 3. So that's how that works. And that's how you get to all that from the keypad. And you can see it's fairly easy. You have to navigate around through the menus, but it's not hard to do. Press the star key to get out of that. And you can see now it's ready to arm. And if I trip this sensor, it's going to go to not ready. So you can see that is learned in. All right. So now I'm going to show you how to do those same things from the ELK software. And if you thought the keypad was easy, well, just hold up, because the software is much easier. Okay. In the software, under Zones Inputs, if you're just setting this up, you've just hooked up the transceiver and got it enrolled on the data bus, you're going to need to add a wireless group. Now I happen to already have one here in my software, but I'm going to show you really quickly how you can do that. So if you right click on Zones Inputs, you can go to New Wireless Zones, and this is where you can select the group number. Now typically you would go ahead and start your wireless at 2, which I've actually done here, and that's why that option is grayed out. But if you wanted to have more than 16 wireless zones, and of course you can have up to 144 wireless zones, so this is how you would add more groups. If you click OK there, then you can see now I have 2 groups of wireless. I'm going to go back to my group 2, and you can see here I have some programming related to my recessed. I've got that as an interior zone. I've got the key fob here. I would actually need to set that to definition 15 for key fob. And I could receive the data from the control end. So if I go ahead and establish a connection here with the control, I'm going to be able to receive those ID numbers that I learned in through the keypad. Now, I'm going to tell you something really important here. If you're using ELK and the keypad both during your wireless setup process, it is imperative that you do not have ELK connected while you are learning zones in from the keypad. This will cause you problems, and then as pleasant as it may be, you and I, or you and someone else in our tech support department is going to be on the phone trying to work through that. And while we love talking to our customers, we know that you would probably rather, just forego that so that you can go on about your day. So just do not have RP connected while you're learning sensors in through the keypad. It's very important. So let me get my RP back up here, and I'm just going to receive all of these items from the system. And so now when I go into wireless setup, you can see these ID numbers that I've already learned in. So I'm going to save that. But now say I want to learn in another zone, and I'm just going to do that off from the software. So I need to go into my group 2, and I'm going to start with zone 19. And let's just say this is a 60-20 slimline that I'm learning in here. So I'm just going to name it that for the sake of naming it something at the moment. And set the zone definition. And you can see here you have a wireless setup button. So if you go into that, this is where you're going to see a lot of those options that we were looking at in the keypad. You have a place here where you can put in your ID number, and so you can just key that right in. I'm just going to put in one here from a sensor that I have on my desk. So that learns in, and you can see it replaces the DL and the HID with these numbers that really don't mean anything to us. We want our ID number in TXID. Now we have a loop number option here. We do need to set that for a lot of our sensors, so you can just key in the appropriate loop number. We have a drop-down box here for our supervision. There are your 3 options, so we're going to leave this one on normal supervision, but if it were a smoke detector or a key fob, we'd want to change that. If you have a key fob, you can set a key fob ID, and that's for your logging purposes, so that when you use that key fob to arm and disarm the system, it tracks that by user in the log, so that you can have that information available. Option 1 and Option 2, again, I was talking earlier about the 6022, and that's this 3-zone sensor. It has the 2 external contact loops, loop 1 and loop 3. So if you are wanting to use a normally open external device with one of those loops, then you need to set Option 2, and so this is where you'll find that Option 2 in the software. So you can see through the software it's just drop-down menus and check boxes and you're done. And so that's how you learn them in from ELK-RP. Alright, so it looks like we had a question about the key fob and programming the buttons, and that is great because that's what I want to show you next. So you have the wireless setup button here, and that pulls up this change wireless zone screen. That's the wireless setup that is specific to that zone. But if you'll notice here on the left side of the screen here in our folder options folder items, we have wireless setup. Now this is slightly different wireless setup than the one that you get to from the zone, as it gives you more options. It's more of a global wireless setup, I guess you would say. And the important thing I want to show you here is the key fob events. This is how you determine what a key fob button is going to do. So by default, your button 1 is arm away and button 2 is disarm, and you can see those options there. Now you can set other options, like if you wanted to set button 4, which is the red button, if say you wanted to set that to a panic, we could select police alarm, and now that's going to be a panic button. Now button 3, you can program button 3 to do a function other than the inquiry, but it does work a little bit differently than the other buttons, so that's important to note. When you press button 3, it's going to give you the inquiry information. If you want to have it perform another function, like let's say you wanted it to arm to stay mode, we can go find key momentary arm stay here and assign that to button 3, but you're going to have to press and hold button 3 for about 4 seconds or so to actually activate this programmed option. The just momentary press of that button is going to activate the inquiry, and you can't really turn that off. That's built into the key fob, but you can have a press and hold function for button 3, and so if you wanted it to say arm stay, that's how you would program that. Okay, I'm going to skim past these few screens here where we were just showing you in the PowerPoint for later reference how to do the things that I just showed you live. Now you can put the system in walk test mode, and that's going to allow you to test all of your sensors, and like with the motion detector, you don't have to go to the motion and do anything. Walk test mode is activated through the two-way. To get to that from the keypad, and again that's really the only way that you can get to it, you're going to follow the instructions here on the screen. And I'll just pop my webcam back up real quick and just step you through that. It's very easy. You press the ELK key, you press 3, which takes you to walk test area, and then you press the right arrow key, and now you're in walk test mode. And so if I take my sensor that I learned in and I go ahead and trip that, you can see now that it's come up there with the name that I give it, which is its part number. So that's how you can test that. And I just armed it with the key fob. So okay, so let me get this going again for you. All right, so why do your customers want two-way wireless? Well, we've pointed out a lot of things that should make that an obvious answer for you. I mean, it's going to be more reliable because you have that two-way communication and the acknowledgement. You have unique features like the sound dial of the smoke detectors, which really, solves a problem in some retrofit situations and getting it up to code. The key fobs are very convenient in providing that two-way feedback. So, for me, it's great to know before I enter the home that there's an active alarm. Like if I can use my key fob to find that out before I've opened the door or walked into the house, and that just makes me feel safer, and I think that's a really great feature. You've got the extended battery life just through not having to blast out a bunch of signals at full power, and also the other things that we're doing with the saving of the battery through acknowledgement and through some of the other features like the RF power optimization, that sort of thing. So that's going to help your batteries last longer, and that's a big thing with wireless. So I'm going to go ahead and open up to some questions now, and I spotted one earlier that I think is a great question, and I want to go ahead and address that. It is a question about a checkbox option that was in our wireless setup. So let's just go back and take a look at that. So we were looking here. There's this option here. This device is a PIR. There is no need with ELK's wireless to ever select that option. That option relates to the GE wireless, their one-way wireless that we can support. Their motion detectors do not provide a restoral, so we have to automatically restore those to reset them basically in our system. But that does not apply at all to our two-way wireless. Jesse, did we have any other questions that I'm overlooking here that we haven't answered?
I'm just trying to look through them and see pricing between one-way and two-way. Do you know anything about that, Amy?
I can't really provide any specifics or numbers there. The two-way technology is advanced, and so you are going to see a increase between a one-way and a two-way on the pricing, but as far as like how much that is, I really couldn't provide any information on that. What you're going to want to do there is just follow up with your distributor, and we can try to put some information together, but we're really not in a position to be able to provide actual pricing on that to you in a follow-up email. So if you want to get in touch with us, or again, better yet, contact your distributor, because they're going to be able to tell you what you're going to pay for something.
I definitely agree on that. Some people are asking about our Keyfob panic button. They are two products that the battery is not replaceable. When the battery does die, pretty much the only option is buying a new one. So we are working on a product that hopefully you can change the battery, but there's nothing that really we can say about it right now. But yeah, the battery, non-replaceable, but you could typically get a good 5 years out of it, just depending on the usage.
Right, and it is going to send a low battery signal when the battery gets low, so you're going to get some warning that the key fob's, the battery's about to die on it. It's not just going to stop working one day. You're going to get that low battery indication, which will show up on your keypad, will be in your log. You can, set up reporting and notification on that so that you can know that that's going to happen. But it lasts about 5 years, and it just depends on I guess how you're using it. But just to tell you, like my husband, for instance, he has a key fob. We've had an M1 system in our house for quite some time, and so we had an older style GE key fob, and he carried that thing around in his pocket for about a year, and it was all the screen printing was rubbed off of it. It had grime all up in it, and it was just a really kind of a sad sight after a period of time. So I mean, 5 years in some people's hands is going to be more than enough on that. But as Jesse said, we are looking at possibly offering a option in a Keyfob with a replaceable battery. So just be looking for that sometime in the future, although we couldn't say when.
Here's a good question. What is the procedure of adding a receiver for extra coverage in a large area where some sensor, like the frequency, isn't being reached?
It's actually very easy to do that. Again, the main thing is your addressing. The data bus addresses are the primary concern when you're adding another transceiver to the system. So your first one has to be address 2, and then the addresses should follow sequentially. So if you're adding one more, then that one's going to have to be at address 3. And there can be no hardwired zones in group 3, so zones 33 through 48 are off limits for hardwired zones, even if you're not going to actually be using those zones for wireless. So you have to keep that in mind. But other than that, it's just a matter of making proper connections to the data bus, set the address, and enroll it. You do not have to worry about is that sensor learned into that transceiver, because that's not how it works. The sensors are learned into the memory of the M1 control. So it's just a matter of which transceiver picks up the signal and sends that back to the control as far as that's concerned. So don't have to worry about doing anything with your existing two-way zones. You just add the transceiver, enroll it, and you're good to go.
Here's another good question, and someone asked, can you mix our two-way wireless with GE and Honeywell, since we do work with GE and Honeywell receivers or sensors?
That is a great question, and I'm happy to say the answer is yes, you can mix those. So again, main thing is the address. Your two-way has to be at address 2. So let's say that you have an installation where maybe you want to add the smoke detectors in this installation, but you've already got some GE stuff there, we'll say. And you've got your M1XRF EG receiver set to address 2, and you've got your wireless setup started at zone 17 for your GE sensors. So unlike the hardwired, where you're going to have to just take that out and redo it, move it to another block of zones and manually add them back in, the main concern again is the address. So you would have to change the address of your existing one-way receiver so that you could set the two-way to address 2 and then do the enrollment. But what you don't have to do is move your zones at all. Because it's all wireless, it doesn't matter that the address of the two-way is occupying the, where you have your GE sensors in. The system is able to deal with that without you having to move the wireless zones. So that's a little less painful than if you have hardwired at address 2. Not going to be quite as big a deal in programming, because you're just going to, like I said, basically make an address change and do an enrollment and add your new zones and you're good. Okay, so there was a question, I did see this one earlier, and that was the one I thought I was missing before. It was about our outputs 4, 5, and 6. And I talked about how those work with the motion detectors. Now, that activates all of the motion detectors. So if you have a motion detector that you do not want to follow this security light as far as like your rules, there's one that you don't want to do that, that's what the jumper inside, or the dip switch inside of the motion detector allows you to turn that one off so that it doesn't respond to those commands. But the commands are global to all enrolled motion detectors, so the LED can only be turned off in that regard with the dip switch.
One gentleman asked, our city is now requiring dual detectors, both ion and photo. Is this only a single? Talking about the smoke detector.
Yeah, our smoke detector is a photoelectric, so it's not ion. We'll pass that along to our engineering team, as that's something I'm sure that they'll want to know about and take into consideration, but our current smoke detector is photoelectronic.
Regarding the PIR, what if you wanted to leave the LED on longer than 17 seconds?
Okay.
Regarding like a fire alarm at night.
The LED is going to do some things on its own that you don't have to write rules for. Like if there's an alarm, it's going to come on anyway, so you don't have to worry about writing rules for that. The purpose of the rules was to allow you to, have that brief activation of that LED and have control of that. But as far as like alarm and that sort of thing is concerned, if you have the dip switch set for it to come on, it's going to do those things on its own. And again, I'm referring to coming on when there's an alarm. It will flash during audible alarms on its own as long as the dip switch is set correctly.
And then we have a question regarding the screen that everyone sees right now. There is a section called Attributes with all those checkboxes. What is that?
Okay, those are your attributes for any zone. So this would apply to hardwired zones and wireless zones, and I'll just go over these with you. So silent alarm means that the sounders are not going to be activated. That's still going to be logged and can still be reported, but you're not going to hear it. You may also want to make note that if you have a zone that has silent alarm selected, you're not able to trigger rules from that zone. But again, that's definitely something that would be desirable in certain cases for it not to activate any sounders. You can set a dialer delay, and where you set that, I'm just going to hop right quick over here to our area RCs under communicator. And you can set a dialer delay here in seconds. So let's say that you have that set up for 30 seconds, and then we come back to our zone here and we have the use dialer delay selected. That means when this zone goes into alarm, it's going to wait 30 seconds before it actually dials out. And during that period of time, you can set up things for alarm abort and alarm cancel, but this determines which zones actually follow the dialer delay if it's enabled. Listen in refers to our two-way listen in option for the M1 Gold system. That is for alarm verification. So your central station can use two-way listen in to verify that the alarm is legitimate before they dispatch, and so again this selects which zones actually use that. Bypassable, I think most people get what that is. It basically, when a zone is bypassed, the system ignores it completely. It remains bypassed until an unbypassed command is issued or the system is disarmed. Now that differs from force arming. Force arming, when you have a zone that's open and it's force armable, you're allowed to arm the system with that zone open. You do have to use a code entry to do that as opposed to a quick arm key, but it will allow you to arm. And it's going to ignore that zone as long as it is violated. However, if that zone goes back to a normal state, the zone is back in the alarm loop, and if it is violated after that, it is capable of creating an alarm, and that's how it differs from bypassing. Swinger shutdown prevents the zone from sending more than 2 alarm signals per arm cycle. So that's for a zone that may be a potential runaway. You don't want it to just be blowing up the central station with reports. You can set the swinger shutdown on it. Periodic trip. This means that during a disarm cycle, the zone must be tripped at least once before the system will be allowed to arm again. And so an example of that might be a motion detector in a warehouse, and then you've got a big pallet stacked up and it's blocking the motion's view, so it's not able to see anything or get tripped. So if you have a case like that, you may want to set periodic trips so that someone has to check and make sure that motion detector is able to actually do its job before the system can arm. Fast loop response relates to how quickly the system responds to a zone, and so that really doesn't apply to wireless at all. That's for hardwired zones. And you have 2 different loop response times, so if you have fast loop response selected, it's going to go to based on that time. If you have do not have this selected, it will go to the slow loop response, and I'm throwing air quotes as I say that because we're talking milliseconds here with either one of those, and those times are set here. So fast is 40 milliseconds, slow is 400 milliseconds. And again, that just determines which zones follow that. Chime enables the chime as far as that zone being able to either make an announcement or make tones at the keypad when the chime feature is turned on. If there's certain zones that you don't want to do that, you leave that turned off. A good example would be a motion detector. You most likely don't want chime on it. In cross-zone pool, this means that more than one zone has to be tripped that's in the cross-zone pool before an alarm would be created. So you can have, say, zone 19 and zone 20 are both in the cross-zone pool. You would have to trip one and then the other within a certain period of time to create an alarm. You can also have this self-verify where you have to trip one zone twice before it creates an alarm. And again, that's just a false alarm reduction feature. So I know we've run out of time here. I wanted to go through all those with you because I know sometimes that can be a little confusing with all those checkboxes, but we will provide a follow-up to any questions that we were not able to answer because we have run out of time. I'm going to hand it back over to Jessie to send us off.
Yes, thank you so much, everyone, for joining us today. If you have any questions at all, do not hesitate to call or email us, Amy or myself. But I do want to remind everyone that next week we will be at ISC East in New York City. So come by, check us out, booth 443. You can see all of our wireless products there. Go by and see Trudy and Kirk. They can, if you're new to the M1, they can give you a full-on demo of the M1 and our wireless products. But check us out next week, Wednesday and Thursday. And if you have any questions at all, do not hesitate to contact us. So thank you so much for visiting or coming to our webinar. Check us out on social media, Facebook, Twitter, LinkedIn, YouTube. YouTube does have a lot more how-to videos on all of our products, so check that out. You might, instead of calling us, you might see it on YouTube. And we also have a forum on our website, so go check out elkproducts.com, and under the support tab, there's a M1 support forum that if you want to search there for your question, or you could even type it there, you can definitely do that. But thank you so much for attending, and have a great weekend.